Today you're learning how to add and subtract radicals. If you need a little more than this video will provide, there's a YouTube link here next to the lesson title that can give you another perspective and maybe some more help. Please do the warm-up now by pausing the video, and when you resume, I'll go over the answers with you. Okay, I've put an asterisk next to the answers for each of these. How did you do? Make sure you do the factor tree. 54 is 9 times 6. My 9 breaks down to 3 times 3. I have a pair of 3's, so 1 3 comes out and gets multiplied to the 2 that's already in front. That's what's right here. And then this other 3 and 2 from the 6 gets multiplied and left under the radical because it didn't pair up. So 6 square root 6 is my final answer. For the other one, 75 is 25 times 3. 25 gave me a pair of 5s, 5 times 5. That 3 didn't pair up. Notice it stayed under the radical. Any pairs come out. 1 5 comes out of the radical. I had x to the power of 12. That's 12 x's. If I draw them all and circle up pairs, I have 6 pairs. That's where that exponent of 6 comes from. If any didn't pair up, they would stay under the radical. All right, for the vocabulary, we need to talk about like terms. Radicals that are like terms have the same index, so either all square root or all cubed root or anything like that, and the same radicand. That's the stuff under the radical. It has to be a match for you to add two terms together. In the same way you could add 4x plus 7x and get 11x, you can add 4 square root 3a plus 7 square root 3a by just adding the numbers in front, 4 plus 7, and get 11 square root 3a. Notice the square root part doesn't change. Also, notice that if there's another term that's not a like term, that just gets put in the answer as part of it. You don't do anything to it. You can't combine it with anything because it's not square root 3a under the radical. It's just square root a. It has to be an exact match. It's not a like term. It's part of the answer, but you leave it alone. Let's do some examples together now. Okay, I've written out all the steps first so that I can walk through them with you. Notice we have like terms here. Both of these have square root 6. So all we have to do is take the numbers in front, the 5 and the 3, and add them together. Now I wrote the step so that you can look back at this and see how to do it. For your notes, you should write every step as well. Don't assume that you'll remember what to do when you look back at it. 5 plus 3 is 8. My final answer is 8 square root 6. For this one, notice I didn't have like terms to begin with. And so here's the part that's generally going to come up for you. They're not going to match, but this square root 27 can be simplified. And so you need to do that first. 27, do the factor tree, 9 times 3. 9 is 3 times 3. That gave me a pair of 3's and a leftover 3. The leftover 3 stays under the radical. Do you see it? It's right there. The pair of 3's came out as 1 3, and that gets multiplied to what's already in front of the radical. So that's the 3 times 2 in front, square root 3. I still have this minus square root 3 here. 3 times 2 is 6. 6 square root 3 minus, look what I put in here. I put a 1. Guys, the same way you have an x without anything in front of it, if you need a number there to work with it, you can put a 1. Because a number in front of a radical is being multiplied to that radical, and multiplying by 1 doesn't change the value. So when you need it, like you did here, you can put a 1 directly in front of the radical, because then I have like terms. Both of these have a square root of 3, and I just have to subtract, in this case, the numbers in front. 6 minus 1 goes in front. Square root of 3 goes at the end. 6 minus 1 is 5, and I have 5 square root 3 as my answer. So the thing to remember when adding and subtracting radicals is to make sure every radical expression is simplified, particularly if you don't have like terms already. Look to see if one of them or more can be simplified. Then just add or subtract the coefficients of each radical. Okay, you knew there would be more, right? We're going to do these together. I know they look a little scary, but keep in mind, we're looking for like terms, and these have the same radical. So all we have to do is take the stuff in front and add it together. Notice, negative 6x plus 2x. I put it in parentheses just to show you what I'm doing. I have square root 7y. All I'm doing is adding what's in front of the radicals. Since they're already like terms, the underlined pieces match. Negative 6x plus 2x is negative 4x. I just keep the square root of 7y. That is my final answer. So, yet again, this other one does not have like terms, and we need to make it like terms. To do that, I can see this can't be simplified. Square root of 2y is what it is. But I can do something with this square root of 32y, because 32 is 16 times 2. 16 is a perfect square, 4 times 4. Even though those 4s can be broken down more, it's just going to give me pairs of 2s. Once I have a pair, I can stop. That 4 comes out and gets multiplied to what's already in front. What doesn't pair up stays under the radical. So now I have 4 times 3x, that's 12x. My 2 didn't pair up, and I never touched that y, so that's still under the radical. And now I have plus 5x square root 2y. Look, now I have like terms. All I have to do is add the stuff in front. So 12x plus 5x goes in front. Square root 2y goes at the end. 12x plus 5x is 17x. And I just bring down my square root 2y. No doubt this takes some practice, but you're going to get it. So on the next slide, I want you to try these on your own. Use my examples to help you. It's the same pattern. The first one is already like terms. The second one, you're going to have to simplify. My advice is to simplify the square root of 28 and go from there. Pause the video, try your best to do these now, and when you resume, you'll be able to check your answers. Okay, check your work. Pause if you need to take it in. We have like terms here, square root 5x. So I circled what's in front of them. I added them together. I got 11x to the third. Remember, when you add like terms, you don't change the variable part. You just add the numbers together in front. And the square root of 5x just comes down. This is my final answer. For this one, I had to simplify the square root of 28. 28 is 7 times 4. That'll generally work out. Remember, you want a match here. So the thing that doesn't pair up was the 7. That's good. We need it. 4 breaks down to 2 times 2. There's a pair of 2s. The 2 comes out and gets multiplied to the 3 that's already in front. So 2 times 3 in front. 7 didn't pair up. It stays under the radical. All right, I brought down my 4 square root 7 for the front. I haven't touched that yet. I just don't want to forget about it. So now I have 4 square root 7 plus the 2 times 3 became 6 square root 7. I have like terms, both square root 7s. I add the numbers in front, 4 plus 6, square root 7, and I get 10 square root 7. No doubt it's going to take some practice. When you're done watching this video, you're going to want to take a little break when the teacher tells you, and then come back and do some more practice in IXL. Okay, we're going to do one more, and this one is a real world connection. And then you'll have one that you can try on your own. So for this, you're given the side lengths of a triangle, and you're asked to calculate the perimeter of the triangle. Perimeter just means the distance around. So you literally add up all the sides. 3 square root 2 plus 4 square root 2 plus square root 50. So I think you can both see, or you can all see, that you have a couple of like terms here, but square root 50 could be a problem. We need to look if we can simplify it. And I know we can, because 50 is 25 times 2. Think money. 25 times 2 is 50. 25 gives me that pair of 5s that I like. And I can make square root of 50. 1 5 comes out. And 2 didn't pair up, so it stays under the radical. And look what I got. 3 square root 2 plus 4 square root 2 plus 5 square root 2. Those just came down. Now I can add all the numbers in front because I have 3 sets of like terms. 3 plus 4 plus 5 square root 2. This gives me 12 square root 2. And that is the perimeter of the triangle. So now you guys are going to try one. We have the length of a truck and trailer given by 8 square root 50. The trailer alone measures 7 square root 32. And you're going to find the length of the truck's cab. So just this red part is what you're looking for. Take the whole length, subtract the trailer, and you will get the length of the cab. I want you to try this on your own. Pause the video and come back when you're ready to check your answer. Okay, how'd you do? This is the length of the cab. 12 square root 2. You had to simplify both of these. 50 is 25 times 2. That's 5 times 5 for 25. 1 pair, so 5 gets multiplied to the 8. That's where my 40 comes from. 32 breaks down, 16 times 2. 16 is 4 times 4. 4 comes out and gets multiplied to the 7. That's where my 28 comes from. That's subtraction. I don't lose it. What didn't pair up in both of these was a 2. That stayed under the radical. Now I have like terms, and 40 minus 28 is 12. I just keep the square root of 2. All right, you have some IXL practice to do. Don't forget, at the end of class, you'll have an exit ticket, and you need to write what you noticed and wondered in your notes. Have a great day, everyone.